Hi all, I am Reshma KV, Assistant Professor of Computer Science Department from Jyoti Engineering College.
Okay, let's look into a k-means algorithm and example. Here, some points named A1, A2, A3, B1, B2, B3, C1, C2, and some XY points are given. And initially, in the question itself, it uses an Euclidean algorithm distance or Euclidean distance is used to find the similarity between the center point and the the object. That means the distance measure is calculated by using the Euclidean measure. Then initially A1, B1, C1 as the centers of each clusters. It is given. So the k-means algorithm first step is arbitrarily choose the k center points. Here already given A1, B1, C1 are the center points. And the second step is we have to calculate or assigning each object to a particular cluster depending upon the seed point. Seed point means that the mean value. So in the mean value, that means C1, C2, C3 are the three clusters, which is C1, which indicates the first point is A1, C2 is the first point is B1, and C3's first point is C1. C1 is the point itself. So initially assigning A1, B1, C1 as cluster centers. So in the first step, initial assigning that A1, B1, C1 as cluster centers, that means center points are C1 210, that is the A1's value 210, C2 58, this is the B1's value, and C3 which is 1 2, which is the C1 value. So after assigning these, we have to choose the next value, that is an A2. So in the next step, the iteration starts. The first iteration starts. Take the point A2 as and find out the Euclidean distance between these three clusters. So we should know that the center points of three clusters. Depending on these three clusters, we have to find out the Euclidean distance. Euclidean distance which calculates, which is equal to square root of the observed value minus the actual value square plus again the observed value minus actual value, the all square. This is the Euclidean distance. Here the observed value is A2's the 2 points, that is the 2 and 5, 2, 5, xy, that is 2, 5. Here the actual value of the C1's cluster center point is 210. So square root of 2 minus 2 the all square plus 5 minus 10 the all square, which is equal to 5. Again we have to calculate the Euclidean distance between the C2 and the new object. So C2 58 is the center point. Here gives the 2 5. Square root of 2 minus 5 the all square plus 5 minus 8 the all square, which is equal to 4.24. Then the third cluster point is 1 2. Depending upon the 1 2, square root of 2 minus 1 the all square plus 5 minus 2 the all square, which is equal to 3.16. From these three values, the minimum distance gives the 3.16, which is the cluster 3. So A2 is assigning to the cluster 3. So third step is assigning A2 to the cluster C3. So C1 equal to A1, only the element is A1. C2, which is the only element, is B1 and B1, and C3, which contains the two elements, that is C1 and A2. After assigning an object to a particular cluster, we have to calculate or recalculate the mean value. So update the cluster mean, which means that C3 is updated by 1 plus 2 by 2, that is the two x points. 1 plus 2 by 2, then 2 plus 5 by 2, which is the second y point, 2 y points. So the new mean value is 1.5 and 3.5. So this is the step. So we have to take the another point, that is A3. In the A3, 8 4 is the point. We have to calculate again the Euclidean distance. The Euclidean distance, the lowest Euclidean distance is 5. In this 5, there is this cluster 2. We have to assigning these A3 to the point to the cluster C2. After assigning these A3 to the particular cluster, we have to recalculate the mean value. In the 7th step, I have to calculate the mean value, that is The newest mean value is 6.5 and 6. In the third next step, that is B2 is the next point, that is a 7, 5. Again we have to calculate the three Euclidean distance. From these three, the minimum value is 1.12, which gives the second cluster. Again assigning that B2 to a particular cluster 2. After assigning an object to a particular cluster, we have to recalculate the mean value. So the newest mean value is the three points, the three objects, x point by 3 plus then y point by 3. So the newest point is 6.67 and 5.67. After that, the third next point is B3 with the 6.4. Then the calculating the distance value 1.79, which gives the minimum value, which is minimum distance value. After that, assigning that B3 to a particular cluster 2. Then assigning B3 to the cluster 2, we have to recalculate the cluster mean value. Then the C2, which gives the 4 points, x value divided by 4. Then the again y value divided by 4. The newest value is 6.5 and 5.25. After that, the last point is a C2, which gives the 4, 9. Again calculate the distance value. 2.23 is the minimum distance value. This 2.23 is given by the cluster 1. So assigning this point C2 point to the cluster 1. Then A1 and C1 is the two elements. Then assigning this second element, last element to cluster 1, we have to recalculate the cluster mean. That the C1's newest value is 3 and 9.5. This is the here all the objects have to be taken. So the first iteration ends and the center point is get with 3, 9.5 as a C1, C2 as 6.5, 5.25, C3 as 1.5 and 3.5. This is the cluster mean or the cluster center points. After the first iteration, there are three clusters which contains C1, A1, C1, C2, B1, A3, B2, B3, and C3 which contains C1 and A2. This is the first iteration. We have to repeat again until there is no change in the cluster list. That time itself, then we have to iteration should be repeated. Otherwise, we should assigning, or the user had to specify how many iterations have to be used for this particular partitioning method. Until that iteration also, this is also an termination condition. Here, this is a first iteration method. Okay, I think you are clear about this. If you have any doubt in the K-means algorithm example, please ask me. Okay.